Good morning, today I'll give you a brief tutorial about graphics in OpenGL. OpenGL is an API that allows us to make operations from 2D and 3D graphics in a computer. It is a multi-language and multi-platform interface, and it represents the object as a connection of triangles as we can see here. Now let's see what is the shader. The shader is a program that runs on the graphic card which is responsible for making the shadows in the graphics as they were in real life. As we can see in this cube, there are two main shaders which will be defined later. And the pipeline is like a production line. It's the set of processing steps necessary to obtain an image of a virtual scene. Let's start with the first stage of the pipeline, vertex specification. This receives the vertex buffer. The vertex buffer is where all the vertex are stored, as it is shown. Now the second stage of the pipeline is the vertex shader. The vertex shader processes the vertex one by one and transforms the coordinates into normalized coordinates. When a coordinate is normalized, it means that coordinates that are outside the square doesn't need to be drawn. There are 5 steps to normalize coordinates. The first step is the model space. It indicates the coordinates where an object starts. The second stage is the world space, where the object is located according to its position in the world. The third stage is the view space. Now the coordinates are seen from the point of view of the user. The next stage is the clipping, where it gives the perspective or angle in which the user will see the object. The last one is the screen space. The coordinates change to the screen space and are normalized and ready to be rendered. The next stage in the pipeline is the tessellation shading. Here we can see an example of tessellation shading. They cover a cube with small triangles until they obtain a sphere. Then we have 2 stages more, the geometry shader and the rasterization. In the rasterization, we start generating fragments. Fragments are structured with color, depth, and position and texture. As we can see, all of these attributes are saved together in the frame buffer. Then we have the fragment shader stage. We determine the final color and depth of the fragment. Now, as we can see, we have a colored pixel. Textures are another important concept. As we can see, there are details and life and save resources. Now let us present transformation. Transformation allowed us to change this into this. But it is important to mention that we are able to make this because of a matrix. Before presenting what is a matrix, let us present translation and rotation. Translation is when an object moves from one place to another, and rotation is when an object turns on its own axis. We use matrices of 4x4 in order to be able to make operations between vectors and matrices. Also, we use matrices to store important information of the object, such as axis of rotation, translation vector, and matrix of rotation. The matrix on the left is the matrix of translation. The result we obtain which will be the new position of the object. Matrix on the right is the rotation matrix, which indicates in which axis is rotated and its angles.